Alright, so good morning everyone again. Welcome to APNIC eLearning web class. This is the first session for today. Wednesday is what we consider as the eLearning Wednesday. And the first topic that we are going to cover is about IPsec. So we will be covering the basics, some things that are necessary, such as the components that are used for IPsec and how it basically functions, how all these components are used together to set up the IPsec tunnel. Now, a few housekeeping things before we go on to that. Today is the 19th of March in 2014. As I've said, it's 10:30 in the morning from Brisbane in Australia, where I'm broadcasting this class. I also would like to introduce myself very briefly. My name is Cheryl Hermoso. I work for APNIC. APNIC, as you know, is the Asia Pacific Network Information Center, the Internet Registry for the Asia Pacific region. Now, I am part of the training team, and we conduct and deliver face-to-face workshops, trainings, and tutorials, and e-learning type of sessions such as this. And the topics that we do cover is it's very vast. That includes Internet Resource Management, of course, IPv6, DNS security, network security, and of course routing. Now, just a reminder that this class will run for 1 hour. Now, at the end of the class, I will be asking you to fill in a survey for us, which is very important so that we know, we'll get a feedback from you on how this went on for you, and also if you have anything that you wanted to add, maybe other topics that you wish to be discussed in the futures and things like that. So with that, I'll just briefly go through what we are planning or what we are hoping to be covering. So essentially, IPsec is a type of VPN. It's a standard of VPN. So we'll just have a very brief overview of VPN and the different standards that are used for the earlier versions of VPN, which is just an introduction to what IPsec really is. And then we will dig deeper into IPsec and look at its benefits, look at its different modes of how it works. Like there are two types, tunnel and transport mode, and we'll look at the different components, as I've said, which comprises the IPsec architecture. Things like security associations, ISAKMP, authentication headers, ESP or encapsulating security payload, internet key exchange, those are components of IPsec. What are the functions of each of them, and what are they used for? And finally, at the last part, we will be looking at the process itself of how to create the IPsec tunnel using these different components and how they would exchange keys basically and establish that connection. All right, so that's what we're planning to cover. Hopefully, we will have enough time to do all of these things. So let me begin by looking at VPN. So VPN, I think you're familiar with this. VPN is quite an old technology now. It has been around since probably the early 1990s. VPN stands for Virtual Private Networks. So essentially you're looking at here at combining different networks, maybe a main office that wanted to connect to a remote office, and we want them to belong to the same private network. So one way to do that is to use leased lines, and leased lines are very expensive because they are dedicated lines. So VPN is a solution to that dilemma. Like, how do we make these connections still possible? Like you still have a private connection, but you're not using a dedicated line. Everybody uses the internet, so why not use these public network? So VPN essentially is a way or a protocol that creates a secure tunnel over a public network. The tunnel is created by either, of course, encrypting or encapsulating the data as it is transmitted across your VPN tunnel. So a common application of VPN is, as I've said, if you are establishing remote connection between offices, or maybe if you are traveling, or if you are outside of your home network or office network, and you are allowed to remotely connect to that office or your work network. So VPN establishes a secure, which means when we say secure here, it means confidential, authenticated communications. Okay, so VPN establishes that type of communications channel. There are two types, which is site-to-site VPN and also remote access VPN, which, as I've described earlier, is mainly if you're connecting multiple fixed lines or fixed sites, or if you have a mobile user that connects to an office or a work network. Okay, some VPN protocol standards that are used by VPN even from before are the following. You have PPTP, okay, point-to-point tunneling protocol. It was developed by Microsoft. It was commonly used, of course, in the early days to secure dial-up connections. It operates on the data link layer. Now, at the same time that they were coming up with PPTP, another organization, another company, this time Cisco, was developing their own version of VPN essentially. It also operates on the data link layer. It's called L2F or layer 2 forwarding. And if you look at the specification, it's essentially the same as PPTP. So the IETF or open standard is actually a combination of these two, and it was called L2TP or layer 2 tunneling protocol. Nowadays, if you look at the current standards for VPN, you will also see IPsec. IPsec is the open standard for VPN implementation. However, what differentiates it from the other VPN protocols is that it no longer occurs or operates in the data link layer. It operates on the network layer. Okay? Commonly, it is implemented not on the data link layer, but on the network layer, and which type of components or equipment uses or are operating in the network layer? Essentially routers, right? So it is usually implemented or configured in routers. Now, let's focus more on IPsec. As I've said, IPsec, of course, is used to provide security on the IP or the layer 3. So IP layer or layer 3. Considering that, of course, all internet devices nowadays are engaged in some form of IP datagrams, we use IP addresses, okay, in one form or another. So the value of security at this layer is very obvious. So IPsec can provide us with that type of protection for all the communications that are either from one end node to another end node, or maybe from one network to another network. Okay, it provides us with protection for these types of communication. Now, there are two types or two modes in which IPsec will operate, and that depends largely on the two types of VPN that we've discussed in the previous slide. We said that you can set up either site-to-site VPN or a remote access VPN. And the two types of IPsec, which are tunnel mode and transport mode, are actually used most frequently as either one of these two, as either for site-to-site VPN or for remote access VPNs. We will learn more on that as we move on in the next few slides. Now, what else do we have here? IPsec combines different components. I've briefly mentioned that in the overview. The IPsec architecture is huge. It's quite complex. This is really why a lot of engineers, a lot of people get discouraged on learning more about IPsec. It's because of the complexities. Not just that, it's also because there are different ways or different even naming conventions and terminologies that are used in different implementations of IPsec in different devices, right? Different manufacturers have their own ways of somehow implementing IPsec. But essentially, at its very core, the IPsec architecture combines several different components. So you'll have to read through a lot of RFCs, documentations, standards about these different components to have a full grasp or understanding of what IPsec is. Okay, but these different components include security associations, okay, authentication headers, encapsulating security payload, internet key exchange. We normally just call them by their shortened or abbreviations, which is AH, ESP, and IKE. So these are the basic things that you need to understand about IPsec. How all these different components work or function. So we have another one actually, our ISAKMP or ISAKMP, some people would call it that way. It stands for the Internet Security Association and Key Management Protocol. It's basically for management of all the keys that are generated as we set up our VPN tunnel. Okay, it's a system that defines how your VPN server and your VPN client will set up or will use what we call as the security associations. So we'll look more into how or what is the function of all these. Now, why IPsec? You will see that IPsec has gained a lot of popularity in maybe in network operators groups, in a lot of network-related conferences. That's because, as you know, IP is insecure. As with all other protocols that started out really early, most of it don't have any security in place, and that's because there is trust that is inherent on the networks that connects to the internet, or the early versions of the internet. So IP itself is insecure, but we cannot run in an insecure network, and we don't want that. So IPsec is originally designed to do that, to provide security in the IP layer. Now, originally as well, IPsec was designed to be part of IPv6, the IPv6 protocol, not for IPv4. Okay, it is meant to be a built-in security protocol for IPv6. However, since you know that it's been taking a while for us to migrate into IPv6, there has to be a security component as well in our current version of IP, which is IPv4. So now we have, I think you can say that it's like ported into the v4 so that it will work alongside IP version 4. But with IPv6, the goal was to have IPsec built in as part of the protocol itself. Currently with IPv4, you have two protocols running. You have, of course, your current IP version and IPsec that adds that security component. Right? Now, there are, of course, a lot of possible security issues, source spoofing, replay attacks, and our data not having the confidentiality that it needs, and of course, integrity that it needs, so that when it is received by your intended recipient, you know that, well, it's coming from the right source, or nobody is actually rather confidential information. That's what we are trying to protect, right? It essentially boils down to our data. Okay, so you want your data to be protected. Now, in IPsec, there is provision, there are benefits. It provides these types of protections. All right, more about IPsec standards. As I've said, you will have to look into a lot of RFCs, read through those RFCs if you want a complete understanding of IPsec. So look at these ones. Most of them are in the 4300 series. Before, it's in the 2400 series, the earlier versions. RFC 2401 is actually the earliest, I think the first version of IPsec that describes its architecture, basically the overall architecture and the specifications, including some of the elements that are common to both AH and ESP. Now, there's also RFC 2402, which discusses AH, RFC 2406, which discusses ESP, but now the updated versions will be 4302 and 4303. So as you can see, different components have their own specifications. Now, one thing about IPsec is that, as I've said, the standard itself is a bit convoluted. Like its description of AH, description even of IKE especially. Now we have here IKE version 2. So there are two versions of IKE now, IKE version 1 and IKE version 2. IKE version 1 is very difficult to understand. The documentation is horrible. That is why the implementation itself by different vendors varies. Like if we have maybe two different devices produced by different vendors, and you want them to connect via IPsec VPN, then there is a very big chance that they will not work together. But as you know, if it's a standard, if it's open standard produced by IETF, it should be, okay, the specification should be the same. So if you have many different devices produced by different vendors, they should just work. But that's not how it works. So most of the documentation of IKE version 1 especially is vague. So that's why we have IKE version 2, which the goal is to mainly to combine all the additional things that they've added to IKE version 1, and also make a better documentation out of it. All right, so basically, if you want to have a look at the different IPsec standards, these are the RFCs that you can check. Now, more on the benefits of IPsec. So let's focus on this one. What do we get when we implement IPsec, right? So as with all other security protocols, our goal is essentially to provide what? Confidentiality. We want to provide integrity. We want to provide authentication means, okay? So that we'll have a secure data or secure communications process. Now, how do we do all of these in IPsec? Okay, same goals. So confidentiality is provided in IPsec through encryption. Okay, IPsec has support for many different encryption algorithms. If a third party intercepts the encrypted data, what happens? Of course, he could not interpret it. Next is integrity. So when you say integrity, what does that mean? We don't want our data to be modified in transit. So for example, if you have routers at each end of a tunnel, they can have like a checksum or a calculated value or a hash value that can be checked so that we can prove that it came or it has not been altered while it is being transited. Now, authentication, okay, on the other hand, is essentially verification that the other party is who he claims to be. So we have a VPN tunnel. We know that we're connecting to the right source, or the data is coming from the other end of the tunnel, because there is a way to verify. There are various methods to do this. We can have usernames, we can have passwords, we can have one-time passwords, biometrics. But what we normally use for IPsec is either pre-shared keys or digital certificates. So we either use symmetric keys or asymmetric keys that can be generated by both endpoints of our VPN tunnel. Right? Now, IPsec is also not just an attractive VPN technology because of these security enhancements. IPsec also scales. Okay? A wide variety or a wide range of networks can use IPsec because it operates on the layer 3 of the OSI model, or the TCP/IP, if you want to think of it that way. Because of this, because it works or operates on layer 3, as a result, IPsec is essentially transparent to applications. Applications do not require any sort of integrated IPsec support. So it's basically invisible from an application layer data or an application layer protocol. It will just work. So where do you configure all of this? You do it on the network layer, which is on your routers. Now, more things about these benefits. We said that it offers confidentiality by encrypting, it offers integrity, it offers authentication. We've looked at that data integrity and source authentication as well, because if you can check that that the signature, because of its signature, it also gives us integrity, and it also gives us authentication that it came from the right source. But what about this? Anti-replay protection. Now, this is an optional thing with IPsec. Essentially, it has a way of checking whether a packet has already been received or not. What is a replay attack? A replay attack is when maybe you have a man-in-the-middle attack, you have a person or a machine somewhere in the middle of your source and destination, and he is overseeing what's going on, like all the packets that are being passed through. He can sniff on it, and then he picks up the packet, okay, and maybe alter it, or maybe just keep it for to himself for a specific period of time, and then reinsert it back into the communications channel. So when the recipient gets it, there should be a way for him to verify that, hey, I've already received this type of packet before. Okay, that is done by checking a sequence number. So IPsec implementation uses this. There is a field in the IPsec header that contains the value of the sequence number. So when you generate or when you formulate your packet on the source side, you will assign a sequence number, okay? And then when it's received on the other side, there is a way for him to check whether he has already received a packet with the same or a similar sequence number. So if he does, then what that machine will do is definitely just discard that packet and then continue receiving the others. But as I've said, this is optional. Although you have that value, the recipient may choose to ignore it. But yeah, this is a very good benefit or feature of IPsec. There's also a way to do key management. So essentially, when you set up your IPsec tunnel, you will be using a lot of keys. Okay, there are many different ongoing conversations. I've mentioned very briefly about security associations. You will set up many of these associations between your tunnel endpoints. And because of that, you don't want to manage your keys manually. So IPsec has a way of doing this key management by using IKE, or the Internet Key Exchange. Now, just to make things clear, this is where we are operating. As I've said earlier, one of the reasons IPsec is a very good implementation, or a very attractive implementation, is because it is somehow invisible from your application layer. Now, because it works in here, network layer, you set it up on your routers. This source and this destination doesn't exactly, you can set it up with IPsec because you can have endpoint to endpoint, or host to host type of VPN, or you can have router to router. So it depends on what type of implementation, what type of mode you're working on. Then you might need some support on the source side. But if it's router to router, network to network, obviously, okay, everything is just on this network layer. I've mentioned about tunnel mode and transport mode, so let's look at them in more detail. So going back to the very first slide, I've told you that a VPN is normally used for two things. So there are two types of VPN, okay? Basically site-to-site or remote access VPNs. As you will notice, these two modes of IPsec works best in each of those types of VPNs. So tunnel modes are frequently used for site-to-site VPN, whereas transport mode is frequently used for remote access VPNs. But what really distinguishes these two is the way the packets are encapsulated, okay, and sent through. So in tunnel mode, it says here that your entire IP packet is encrypted and now becomes the data component of your new and larger IP packet. So just as a review, if you have data that are passed on to your IP layer, it will have an IP header and of course an IP payload before it is transferred to the lower level, right? Your IP payload now consists of the data that came from the layer above, which is your TCP segment. So that means it comprises of your TCP header and your TCP segment, okay, another payload there. So this is how it looks like. You have an IP header, a TCP header, and a payload, or simply an IP header and an IP payload. Now, as we've said, in here, in tunnel mode, your entire IP packet is encrypted. So look at it this way. So when you encapsulate that, that means that you will now add an IPsec header. This is your complete data, complete packet that is received by your router. Now it will add an IPsec header. And after that, of course, you still need your source and destination addresses, so you will add a new IP header. That's how it is. So in tunnel mode, as you can see, the result is a bigger packet because you're essentially creating a new one. Okay, everything is encapsulated. You add an IPsec header. You also need to add another IP header. As you know, IP headers are at least 20 octets in size, and that is not even fixed size. It can be more than 20 bytes depending on the options that are added there. So that is the result. If you are going to implement tunnel mode, just make sure that you know about this. Because if you have, like, say, a specific MTU size, that limits your bandwidth or your connections, then okay, you might want to change these values. MTU size by default is at 1500. However, it can be set to something lower, it can be set to something higher. So if you're going to use tunnel mode, just be aware of your MTU size. The next mode of IPsec is transport mode. So with this one, it's a bit easier because you are not encapsulating the whole thing. You are simply inserting the IPsec header. So here you still have your usual diagram like the one above here. So you have your IP header, you have your TCP header and payload. So what you do is insert the IPsec header in between the IP header and the TCP header. That's essentially it. Okay, so no new packet is created, and it doesn't result to a larger IP packet. Okay, so if the packet size is an issue for you, then it's better to use transport mode. Okay, so some of the pros and cons between tunnel and transport mode. As I've said, transport mode is usually used for remote access VPNs. That's why your IP header here, okay, is still intact because you will need the IP address, the source and destination IP addresses of your two sites, or your machine and the network that it's trying to connect to. Whereas in tunnel mode, this new IP header, of course, still has a source and destination address, but it will change. It will be the IP address of the machines that are set up to use the VPN tunnel. So in this case, if you have two routers that are set up to use IPsec, so the source address of the and destination address of the routers are used, and not your the endpoints that are sending the packet, right? Because when it reaches the other router, this will be stripped off, so it will still be delivered to the destination address that you have previously identified. Any questions so far? Everybody still with me? All right, I have two extra people in the class, Mujtaba and Sita. Hopefully I pronounced your name correctly. If you did not see the first few slides, and yeah, you can pretty much catch up by the way I explain things, but I will also be providing the materials later on, so you can have a look and you can ask me questions if you don't understand some parts of it. All right, so let's continue. Let's look at the IPsec architecture. I think all throughout, since the beginning, I have been putting emphasis into this architecture. We said that IPsec is actually an architecture. It consists of many protocols. We've looked at the different RFCs that discusses each of them. But in a just so it's more digestible, let's look at the IPsec architecture in this way, right? So we have what you need before you implement any security protocol, of course, is a policy. Your company, your organization has a security policy. Based on that policy, okay, you implement things. You decide what type of parameters are going to use. In this case, you will need a security policy for IPsec. This includes what type of algorithms to use for encryption, what types of algorithms for compression, the number of the size of the key length, okay, and the duration or the lifetime of these keys. Like how often will you change keys? When you have these all set, okay, these parameters will be negotiated with the other machine that you're trying to set up VPN with. So those two machines will need to coordinate, okay, will need to agree on specific security policies. Both of them should have support for these. Okay, so from these security policies, you will have like a security association that is used, as I've said, when you're building up these connections, or when you're setting up, initially exchanging these parameters with the other end, so that both of you will use the same parameters. That is what we call a security associations. these will be stored in a security associations database. So we have two databases here. You have a security policies database, which contains all your essential parameters that you support yourselves. And then you will have a security associations database for each connection that you set up. As I've said, you will have many of these different connections. You will have many security associations. So these will also be stored in a security associations database. These SADBs will have a specific number, okay, a unique number that identifies it, which is what we call as the SPI. All right, so that is for security associations. Now, once you have that, security association is used for both negotiating for either of these three other components: AH or Authentication Header, okay, ESP or Encapsulating Security Payload, and IKE. Now, you can think of it this way. Your AH and your ESP are, of course, your security protocols. Okay, you'll use this to establish the secure channel. Okay, but the actual process of exchanging these keys, exchanging these security associations, and actually establishing the tunnel is IKE, or the Internet Key Exchange. To do that, you will be using either AH or ESP, or you can also use both. All right, Mujtaba has a question about the quality of the video. I'm not sure, everybody, can you answer if you're having issues with the video as well? Because as far as I know, there shouldn't be. Maybe it's your internet connectivity, Mujtaba. Anyway, let me get back to this IPsec architecture. So as I've said, AH and ESP are both for security protocols. IKE is for the actual establishment of the tunnel. And to do that, you'll need to identify, or you'll need to decide whether you will be using AH or ESP, or AH and ESP. So you have the option to use both. So just a brief overview of security associations, which I've already kind of discussed. So the concept of a security association is something that is very fundamental to IPsec. Okay, something that is very fundamental. Why? As I've said, an SA is a collection of parameters. It's a collection of the attributes that is associated with the secure connection. That's why we call it as a security association. This is what you exchange with the other parties. With an IPsec datagram, maybe it's an AH datagram, maybe it's ESP. Either way, if it arrives in an interface, how does an interface know which set of parameters to use? When I say which set of parameters, that means which key, which algorithm, which policies to use. So any host could have many ongoing conversations at the same time, and each of them might be using different set of keys or different set of algorithms. So something must be able to direct this processing. That's what we call an SA. That is the main job of your security association. Okay? Your SA is uniquely identified by three parameters. You have the security parameters index or SPI. You have to identify, of course, the destination address and which security protocol are you using. Are you using AH or are you using ESP? SAs are also stored in a database. As I've said, it's called the Security Associations Database. Now, an SA is unidirectional. So a common communications process, of course, is bidirectional, meaning you need two sets. You need to send data from source to destination, and your destination has to reply back to the source, right? So it is a bidirectional communication. So since security associations are unidirectional, you need two security associations to have your typical communications process. Okay, so one of it in each direction. Right? So if you happen to be using both AH and ESP, then that means that you need to create two security associations for each AH and ESP. So that means you will need 4 security associations already. And that is just for one communication that is using both AH and ESP. That's why I told you that there are many different ongoing conversations, and you will generate a lot of security associations. That's why it has to be stored in a database with its own its own index. Questions? How do you set up or use a security association? Of course, you can always do it manually. It can be manually configured, but we don't want that because of the complexities that are involved with it. The more common way and the more efficient way is to use IKE. Next is ISAKMP. ISAKMP or ISAKMP essentially defines the procedures and the packet formats that are used to establish, maybe even to negotiate, to modify, or even to delete your security associations. Okay, it's distinct from key exchange protocols so that you can cleanly or clearly identify or separate the functions of both. Okay, security associations is mainly managing the SAs. Key management, which is IKE, is in charge of the actual exchange of these keys and of these security association. Okay, there may be many different key exchange protocol, and each of them will have different security properties. Okay, so but you have like a common framework that is used for agreeing the format of your SA attributes, and you can read these through the RFC that discusses ISAKMP. Okay, so you can think of ISAKMP as a framework that's required for agreeing the format of the SA attributes and also for negotiating, modifying, and deleting your security associations. Now the two security protocols are AH and ESP. Let's discuss them together, okay? Just a very brief thing about AH. What was our goal with IPsec? We said we need three: confidentiality, integrity, and of course authentication, right? Now, Authentication Header gives us two out of those three goals. It only provides source authentication and data integrity. So what is missing? It doesn't have support for confidentiality. Okay? It doesn't encrypt. It can only provide you protection for integrity, okay, which can be about source spoofing. It also provides protection against replay attacks. But as I've said, where is confidentiality? Now, there are many instances where you are not exactly concerned about protecting the contents of your data. You're not limiting them to only, okay, the recipients. It's okay to be read through, but you want to make sure that it's coming from the right source. So if that is your setup, then it's okay to use AH. Okay, now AH is already deprecated. Okay, so you still see this being used by a lot of implementations, but AH is already deprecated. If you are still going to use this, okay, AH has less preference over ESP. ESP has more priority over AH. AH essentially follows ESP. It operates on IP. It uses protocol 51. Okay, and as I've said, this is no longer the preferred way of using or of implementing security. What we want is ESP. ESP provides you with all of the three goals, okay, all of those protections. It provides you data confidentiality, it provides you with authentication, okay, it provides you with integrity as well. Now, how do we provide confidentiality? Of course, that's through encryption. You can either use symmetric or asymmetric key encryption, of course, but most of the time we use symmetric key encryption for ESP. What do we mean by symmetric key? We will generate, okay, a key that will be common to both, or understandable or readable by both your source and destination of your tunnel. Okay, now you must encrypt, okay, before you authenticate. So encryption is done on one phase, authentication is done on another phase. Okay, so again, those are the two types of security protocols for IPsec. Now, one more thing, if you want to still implement AH, okay, again, if you're not really concerned about providing confidentiality, then that is now doable with ESP. You can use what we call as ESP with null encryption. Okay, so essentially you're not providing any encryption. That's the technical term for that. ESP with null encryption. Now, I've shown you transport and tunnel mode in the previous, a few slides ago. So how do we implement both transport and tunnel mode if you have AH and if you have ESP? Okay, it's pretty similar. Okay, just a few differences between them. So AH here in transport mode, of course, we are only inserting the AH header in between your original IP header and your payload. So that's what we're doing here. We've inserted the AH header, okay, but which ones are we protecting? Essentially all of the packet. We're providing authentication for all of the packet, excluding the mutable fields. What are mutable fields? These are field values that are checked as your packet passes through different routers before it reaches its intended destination. Okay, because it has to be read through at every hop, then there's no sense of actually including that in the authenticated parts. All right, so things like TOS, TTL, offset, and flags are not included in the authenticated portion. How about ESP? Now this is just a bit different than AH. AH is pretty straightforward, as you can see here, but with ESP, you're encrypting. So you need to know the extent or which parts are you going to encrypt. That's essentially your data, of course, but you need some form of another field there, okay, that tells you that, hey, this is the end of my encrypted portion, and that is your ESP trailer. So you're inserting your ESP header, you're encrypting everything after the ESP trailer after the ESP header, all the way up to your ESP trailer. That is your encrypted portion. Okay. The others, such as your original IP header, are not encrypted. Okay. Your ESP authentication, of course, you don't need to encrypt that. But how do you know? How do you authenticate? How do you know that it's coming from the right source? We are using certificates, right? We are using signatures, digital signatures, or you can have other ways there, but digital signature is the most common one. So where do we add that form of authentication? You have a field here called ESP authentication, which is right at the end or trailing your entire packet. All right, so which parts are authenticated? From your ESP header up to your ESP trailer. We have some more here if it's tunnel mode, just a bit more complicated, but essentially still the same. You still have your AH header, okay, that is inserted, and then you have to add a new IP header because you're encapsulating the whole data. With tunnel mode, again, it's the same thing. You have your ESP header there. It's encapsulating, including your original IP header, so you'll have to add a new IP header. So the end result is actually a lot bigger if you are using tunnel mode in ESP. Okay, now let's go to the other type of component, which is Internet Key Exchange. So far we've discussed the two security protocols, AH and ESP. We've also discussed security associations, ISAKMP and SADBs, and IKE. We haven't discussed IKE in detail yet, but we have somehow touched on it. But what is IKE exactly? What do we do with IKE? Now in IKE, this is the part where we actually set up or configure our tunnels. Okay, IKE is one of the primary protocols in IPsec. It's used to establish the IPsec tunnel. Okay, it uses a collection of the protocols that we've discussed. Okay, so as he can do or he can set up the tunnels. IPsec can provide encryption between authenticated peers using these encryption keys, and they have to be changed. Okay, so IKE, as I've said, allows you to do away with manually configuring these keys whenever it is periodically changed. IKE uses 3 modes of operation to set up these types of secure communication path. We have, I think I have that in the next slides. We have main mode, aggressive mode, and quick mode. Okay, main mode involves 3 types of exchanges. In IPsec, an exchange consists of 2 messages. Okay, one exchange equals 2 messages, one forward and one going back. we have two endpoints. We call it the initiator and the responder. Okay, the initiator is always the first to send messages. So in this case, in main mode, your initiator will send what we call as a proposal. Okay, it will send one or more proposals to the other peer or the responder. Okay, why do we do that? We said that you have, let's say, you have security policies, you have certain parameters there that you support. So you will now check with the responder whether he has support for these things as well. So this proposal includes what supported encryption you have, what authentication protocols, what are your key lifetimes. Additionally, this proposal can also include whether you are using PFS or Perfect Forward Secrecy. PFS is just another way of ensuring that your session remains secure. Even if, let's say, for some reason, your private keys are compromised while your session is set up. So your current existing session is still secure even if the session key has been compromised. Alright, anyway, going back to main mode, as I've said, we're using three types of exchanges. Exchange 1 is, of course, when you send those proposal, okay, the responder has to reply back with what a set of parameter he also supports or what he accepts. Okay, exchange number 2 uses what we call as a Diffie-Hellman key exchange. Diffie-Hellman is an asymmetric key cryptography. Okay, but it is used so that they can establish a same shared key. Once that is done, everything that follows will use that shared key. So we go back to symmetric key algorithm. We have just one set of keys. Now that is exchange number 2. You use Diffie-Hellman to come up with that shared key. And then exchange number 3 is using the ISAKMP, okay, session, so that basically you're establishing the ISAKMP session. Now, aggressive mode is very similar to main mode, okay, but it's actually just a faster implementation of main mode. You're trying to achieve the same thing. The end goal is to set up your ISAKMP channel, okay, using only 3 packets. You're not using 6 messages here, only half of it, only 3 packages. But all the contents are, you try to put that in maybe one packet will have more information in it. So first packet will be what you, again, still initiator, sending the proposals. Second packet is the response, but at the same time, it also starts with the Diffie-Hellman there. And the third packet is used to finalize the authentication for your ISAKMP session. So by the end of this, either you use main mode or aggressive mode, your end goal is to create what we call as an ISAKMP channel. This is phase 1. So when you set up your VPN tunnel using IPsec, you're doing it in 2 phases, phase 1 and phase 2. Phase 1 is what we call as the ISAKMP tunnel or channel, okay, and the security associations that you're exchanging are called, of course, also ISAKMP security associations. Now the other mode of IKE is used for phase 2. Okay, so now at the end of, as I've said, main mode or aggressive mode, you use that to set up phase 1. So you already have a secure channel. So in quick mode, it is used for phase 2. It is used to finally set up your IPsec tunnel. So think of it this way. First, you set up a secure channel. Okay, secure channel between point A and point B. Okay, once you have that, okay, everything, all the connections are secure, it's confidential, it's encrypted. After that, you create a tunnel inside. Now, IPsec is also used for other types of protocols, such as L2TP IPsec, MPLS as well sometimes. Is that right? Yeah, MPLS can somehow also have something similar, like it has 2 phases, but not using IPsec, sorry. But L2TP IPsec actually uses IPsec only for phase 1. So it's used to set up the secure channel. Once they have a secure channel, it uses L2TP to encapsulate all the data so that it can be passed through the IP channels. Okay, you're passing L2TP type of packets in the IP tunnel. So yeah, you can think of IPsec in that way. You have two phases, phase 1 and phase 2, which is actually described here. Phase 1 is where you describe or where you establish your secure channel, your ISAKMP channel, and phase 2 is where you establish your channel between or within that secure channel created in phase 1. It's called the IPsec channel, right? So phase 1 uses main mode or aggressive mode, phase 2 uses quick mode. So this is just an overview of what we've discussed. First, you have your secure communications channel for phase 1, and then you create an IPsec tunnel between or within that before you can actually exchange secure traffic with each other. You can just skip this because this is the description. I've already described this in the previous slide. Just remember the 3 different exchanges that you need to do for phase 1. More importantly, you need to understand what Diffie-Hellman is or how it works. So Diffie-Hellman is, as I've said, asymmetric key cryptography. With asymmetric key, you have public and private keys. Okay. Now Diffie-Hellman is only for key exchange and it's not used for encrypting anything. Okay. It is used so that both of your endpoints can come up with the same shared secret key. You're exchanging 2 values. Okay, 2 big I think, yeah, 2 very big values, and from there it can calculate. Okay, there is an algorithm that can calculate a common value, okay, between those 2. All right, and that will be used to secure the channel for phase 1. Okay, these are the messages that are being exchanged there. By the end of phase 1, you have an encrypted channel. Okay, phase 2, as I've said, is for IPsec SA or IPsec tunnel, which has only 3 messages. And now, if you will notice, your authentication part, everything, hashing is also done here. You only need to worry about the 2 other goals, which is integrity and also authentication, because confidentiality part is already done on phase 1. Now, to just to end this session, we'll just look at some of these IPsec best practices. So essentially, you will be provided options of what keys, what encryption algorithms you would be using. So if you're familiar with these encryption algorithms, you would want to, of course, pick the best one that is supported by your IPsec implementation. So you have the option, of course, to use AH and ESP if you're still has support for that. But if you're given the option or you're given the choice, of course, you'll have to pick ESP if that is part of the choices. Now, how about encryption? Okay, what sort of encryption algorithms do you support? What are the different algorithms? You have DES, triple DES, AES. Okay, AES is the current standard. So that's Advanced Encryption Standard, I think that's what it stands for. But basically, AES is the current standard. If your machine doesn't support that yet, triple DES is not really that bad. Okay, triple DES is very slow, but that may be the best that you have if you have like an older implementation. But if you can, AES should be your choice. How about for hashing? Okay, you will do a lot of hashing, as you've seen in phase 2. So for hashing, you have the options to use SHA-1, SHA-2, or MD5. Now MD is already, it's not deprecated, but they've seen a lot of problems with MD algorithms. So SHA is actually the better option between these 2. Okay, and if you can, if it has support for SHA-2, then go for SHA-2. As I've said, you can also use perfect forward secrecy so that your session is kept secure whether or not your session keys have been compromised or not. But if you're using that and if you're sending very sensitive information or sensitive data, then you can set this to a very low value, okay, so that you only need it for a short amount of time, just so that you can forward that highly sensitive information. And after that, it can negotiate for another set of keys. So you can reduce the lifetime of your SAs, okay, if you enable perfect forward secrecy. And that is the end to the introduction to IPsec. I hope that you got something from this class. There are many things more to understand about IPsec, especially the implementation part. As I've said, implementation-wise, there are many vendors that are differing in even the terminologies that they use, okay, to do this. So it can be a little confusing. It can be down-putting to most engineers as well. But if you just spend more time actually trying to understand how it works, then it is a very good protocol, very appropriate at this time as well. So something that is well recommended to secure your networks. All right, so any questions from the class? If you're thinking of a question right now, what I'm going to do is type in the link to the survey. As I've said at the start, I would really encourage you to fill up this survey so that I have an idea of what other things to include in our future e-learning courses. What's the date today? Oh, 3/19. All right, so this is the link to the survey. If you can please fill it in for me, I would be very grateful for that. Now, if you don't have any questions, I don't see anyone typing in, I would probably just end here and recommend you to also check the handouts. The link to the handouts will be available after you've filled in the survey. So please go check it out and then read through it again. If you have questions, please feel free to send me an email to clarify some things with me. All right, so thank you very much, everybody. If you don't have questions, as I've said, I will end this class now, and I hope that you can join us in the next e-learning sessions. We will have one at 12:30, at 2:30, and 4:30 in the afternoon, so 3 more. And the discussion topics will be, I think, DNS security, BGP, and BGP attributes. So you can just join us using a similar link. Just change EL1 to EL2, EL3, and EL4, and log in as a guest. All right? Thank you very much, and I hope you have a wonderful day. Bye-bye.